Hello and welcome to the Chapter 7 review. I'm going to share my screen. There will be two videos for this review. Okay, so question number 1 is asking us to solve the equation by completing the square. So completing the square is ideally we want to create something that is a perfect, say, x minus 2 squared. That's what we want to create here so that we can use the square root property to solve. So to do that, we're going to take 1/2 of b, so b divided by 2, and that is a -4. And then we're going to take b squared, so a -4, the b divided by 2 squared, so a -4 squared is 16. That's what we have to add to both sides. So that now this is a perfect square of x minus 4 squared. So the b divided by 2 is what's going to be here. And then we have this. And now we can use a square root property that says if we take the square root of both sides, you have x minus 4 equals plus or minus 4. And the plus or minus means that we're going to have two answers. So x minus 4 equals a -4. If we add 4 to both sides, we get x equals 0. Or if we take x minus 4 equal to a +4 and add 4 to both sides, we get x equals 8. So those are my two solutions. Question number 2 is essentially practicing completing a square. So we want to add something here so that we will have a perfect square. So if we take 10 and divide by 2, we get 5. And that's going to be our perfect square. And then the part that we're adding is really the 5 squared, which is 25. So that goes here. So we can see that x squared plus 10x plus 25 factors into x plus 5 squared. So this is a practicing of the completing the square. Okay, questions 3 through 5 are all going to be practicing using the quadratic formula. And the quadratic formula, remember, is a way for us to solve for the x-intercepts. It's taking the opposite of b plus or minus the discriminant here, the square root of the discriminant, which is b squared minus 4ac all over 2a. When we have a squared plus bx plus c equals to 0. So we have to have all the terms to one side equal to 0 to be able to use the quadratic formula. So this is my A, my B, and my C. So I have x is equal to the opposite of a -7 plus or minus the square root of a -7 squared minus 4 times A, which is 12, times a -45 all over 2A there. And so this simplifies to 7 plus or minus the square root of, that'll become 49. And we have a -4 times 12 times a -45. So that's going to be plus 48 times 45 is 2160 all over 24. Then we're going to add what's inside this root. So we have 7 plus or minus the square root of 2209 all over 24. And that simplifies to 7 plus or minus the square root of 2209 is awesome because it is an even, it's an even 47 over 24. So that means that we're going to have two possible answers. We're going to have 7 plus 47 over 24, which is 54 over 24. And that simplifies to 27 over 12. And that simplifies into 9/4. Or we're going to have 7 minus 47 over 24. And that gives us a negative 40 over 24. And that simplifies into negative 5 over 3. So those are the two solutions there. Then we have question 4. Again, it's set up, so we've got A, B, and C. And so when we put that in, we get x equals the opposite of a negative 11 plus or minus the square root of a negative 11 squared minus 4ac all over 2a, 2 times a. So we have 11 plus or minus the square root of 121 minus 52 all over 2. And then that simplifies into 11 plus or minus the square root of 69 over 2. And 69 does not have anything that is a perfect root, so it is going to be finished right there. So let's look at number 5. Number 5, we have set up nicely as well. With A, B, and C. And so we can set this up as the x is equal to the opposite of 43 plus or minus the square root of, and this will be 43 squared minus 4 times A times C all over 2A. Now, I'm really going to just focus on the discriminant here. We've done a couple where we solved for the actual x value, but just looking at what are my possible roots here. If I look at the discriminant, which is the 43 squared minus 4 times 3 times a negative 30, that comes out to be the square root of 1849 plus 360, which is equal to the 2209, which is greater than 0. So that tells us that it's going to be, there's going to be 2 rational roots. And we know from the prior page that the square root of 2209 is 47. So x is going to be a negative 43 plus or minus 47 over 6. And so that will be 2 possible answers. One would be a negative 43 minus 47 over 6, which is a negative 90 over 6, which is a negative 15. Or we have a negative 43 plus 47 over 6, which is 4 over 6, or 2/3. Are my 2 answers there. And number 6. So number 6 says a ball is thrown from a height of 192 feet above the ground. The height in feet of the ball from the ground at any time t in seconds is given by this equation. At what time does the ball touch the ground? So we're asking to find t. We want to solve for t when the ball touches the ground. So that means the height is going to be 0 when the ball touches the ground. So we're going to put 0 in for h. And solve for t. Now, the cool thing is that you can see from my answer key that I scanned in, I did it once with the quadratic formula. But then you can also, if you look, you can factor out a negative 16. And when you do that, this is what you get. And so the 16 is just getting eliminated, which is nice. And then you can try to factor this into t minus 2 and t plus 1. Oh, wait, this is 12. When I factor out a 16, it's 1 and it's 12, sorry. So that factors into t minus 4 and t plus 3 equal to 0. Sorry about that. And then this one becomes t equals 4, and this one becomes t equals a negative 3. And we can't have time as a negative, and so it's 4 seconds it will touch the ground. Okay. Let's move on to number 7. So number 7 is, I give you 3 different equations. Actually, they're not set equal to 0, but they could be. And I want you to determine, using the discriminant, just how many types, what the types of solutions are and how many there could be. So that's all I want you to look at is the discriminant. And remember, the discriminant is b squared minus 4ac. So in this case, it's going to be a negative 5 squared minus 4 times 3 times 20. And that comes out to be 25 minus 240, which is a negative 215. And because that is less than 0, that tells us that we're going to have 2 imaginary roots. Okay, so that gives you a clue on some things. Letter B. Let's do the same. So b squared is 7 squared minus 4 times a times c. And we get 49. And because this is a negative times a negative, it's going to be a positive. So you already know that you're adding, and you're adding 48, which is 97, and that's greater than 0. And so that means we're going to have 2 rational roots. And then the third one, letter C, we're taking a negative 12 squared minus 4 times a times C. And we get 144 minus 144, which is 0. And because it equals 0, that tells us that there's exactly one rational root. And if you've been paying attention to how we can think about the pictures of each of these, because A is positive here in this first one, we know it's face up and there's imaginary roots. So because the imaginary roots means it never crosses the x-axis, and because it's face up, it's going to look something like this. It never crosses the x-axis. Now this one is also a face up, but there's two rational roots. So we know that it's going to cross in two spots. I don't know where, I didn't find that. That's just what I know, what it looks like. And then the third one is face up. And we know it has one root, and you can see that this is a perfect square of x minus 6 squared. So 6 is going to be my root, and then it's going to be face up from there. So just some fun facts about graphing and the things that we've learned about parabolas. Okay, number 8. So 8 and 9 are asking you to come up with an equation if you already know the solutions, which is really cool. And so if you already know the solutions, we can work backwards. So if we know the solutions, then we know that they would have been binomials multiplied together. And so to get this into a binomial, we want to get the x and the 2 on both sides. So if we subtract 2, we get x minus 2 equals 0. And likewise, if we subtract 9, we get x minus 9 equals 0. And that means we would have used the zero product property, and we would have, to get to the original equation, these would have been factors. And so we're going to multiply these factors together, set them equal to 0, and then we can multiply. And so when we do that, and we add like terms, we get this quadratic equation is our possibility. Let's look at number 9. So number 9, again, is asking us to find an equation that has these solutions. So let's rewrite it here. So x equal to -4, if I add 4 to both sides, I'll have this binomial. Now, the one over here, we can't just add 3/5 because we want it to be a binomial of all integers. So we're going to start by multiplying both sides by 5. And then we're going to subtract 3. So we'll have the binomial 5x minus 3 equals 0. Then when we multiply the binomials together, we can get the original quadratic. So we'll have 5x squared plus 20x minus 3x minus 12 equals 0. And then we end up with 5x squared plus 17x minus 12 equals 0. Okay, so number 10 says, determine the value of k in the equation x squared minus kx plus 289 equals 0 if it has exactly one rational root. So if it has exactly one rational root, then it must factor into a perfect square. And so for this to factor into a perfect square, this must be a perfect square root. So the square root of 289 is equal to 17. And so this must be so this would be x minus 17 squared. And so this k must be 34. So this would be x squared minus 34x plus 289. Because it factors into x minus 17 squared. Pretty cool. Okay, let's look at our last two problems for the review. So I'd also like you to be able to find some important things about quadratic equations. And a couple of them are the vertex is important, the x and the y intercepts, and the graph. And indicate whether the vertex is the highest point or the lowest point. So the first thing I always do, hopefully you learned this semester, is I always look at my A. So my A is equal to 1, which is greater than 0. So that tells me that it's face up. And then I'm going to find my y-intercept first, because my y-intercept is always when x equals 0. So when x equals 0, I have 0 squared minus 6 times 0 plus 9. Those two terms go away, and I end up with the 0.09. Then my x-intercepts, if I can factor, that's my first choice. If not, use the quadratic equation. So I'm going to factor, and it factors into 0 equals x minus 3 times x minus 3. So that keeps that easy. So that means x just equals 3. So I have an x-intercept at 3, 0. And it's a double, so I know that it's just touching. Remember, we learned that it's just a touching. So 0, 9 is my y-intercept somewhere up here. 3, 0 is my x-intercept, but let's just see if that's also my vertex. I'm thinking it's going to be my vertex because it happens twice, so it means it's just coming down and touching and it's face up. But my vertex, my x coordinate is always my opposite of b over 2a, which is the opposite of a negative 6 over 2 times 1. So that's 3. And so then I'm going to look at what is f of 3 to find the y coordinate. And so that's 3 squared minus 6 times 3 plus 9. And so that's going to be 9 plus 9 is 18 minus 18 is 0. So it does look like my vertex and my x-intercept are the same value. So it looks like this is my equation in my graph. Pretty cool how we can find all of those things from my equation, and I can make my graph just by finding these things. I can get a picture of my graph without even looking at Desmos. So I am expecting you to show me these things on the test. Hope for credit. Okay, and the last one is number 12. So again, I'm going to look at A is equal to 1, it's greater than 0, so I know it's face up. They won't always be face up. My y-intercept is when x is 0, so those two terms go away, and I'm left with 6. So there is my y-intercept here. My x-intercept, if I can factor which it looks like I can factor into x minus 3, x minus 2. If you can't, you can always use the quadratic equation. So that gives me x equal to 2, x equal to 3. So here is a 2 and here is a 3. And then my vertex, the x coordinate of my vertex is going to be the opposite of a negative 5 over 2a. So that's a positive 5 halves. And so when I put 5 halves into my function, I need to find out what that comes out to be. So that's 25 fourths minus 25 halves plus 6. I need to get a common denominator of 4. So that's going to be 25 fourths. I'm going to multiply this by 2 over 2. So that's 50 fourths. I'm going to multiply this by 4. So that's 24 fourths. And then when I add these together, I come up with a negative 1/4. So my vertex is at 5 halves comma negative 1/4. So it's 2.5. So right between 2 and 3, and it's right here. And that's the graph. So you should be able to factor, you should be able to use the quadratic equation, you should be able to use the vertex form to find the vertex with a negative b over 2a, like we did here. You should be able to do a graph with these things. You should be able to find an equation given a solution, like we did on 8 and 9. Then you should be able to use your discriminant to let me know what types of solutions and how many. And I hope you have a great end of your semester.